So let's look at the mechanism of the reaction. If I just take a generic ketone, right, and let's use methyl magnesium bromide, for example. Maybe I'll use cyclohexanone as an example here. So to show the mechanism, I'm drawing the Grignard reagent as a polar covalent compound. So we can show the electrons from the bond being used to attack the electrophilic carbonyl carbon. This is very similar to the sodium borohydride or lithium aluminum hydride reduction. Just we're using the Grignard reagent instead of the hydride reducing agent. And instead of forming a new carbon-hydrogen bond, we're going to form a new carbon-carbon bond in this case. So now we've introduced this methyl group, and we have an alkoxide intermediate, and then water is introduced once the reaction is complete in order to have a proton source to produce the alcohol product. All right, so this is essentially step 1, step 2, since this is a 2-step reaction. And the product here is a tertiary alcohol. So again, when you use a ketone, you end up with a tertiary alcohol product. What would the mechanism look like if we had used an ester instead of a ketone? So let's look at a simple ester. And just to vary it, I'll maybe use a different Grignard. So I'm going to use propyl magnesium bromide because, again, it doesn't really matter what the R group is. Mechanism starts out very similarly, right? The carbon that has the majority of the electrons in the carbon-magnesium bond will attack the electrophilic oxygen. We'll have to show a resonance arrow to move electrons up to the oxygen of the carbonyl. So this first step forms that new carbon-carbon bond. And then in the case of an ester, we can have loss of a leaving group. So if we move electrons down to reform a double bond, we can kick out this oxygen as a leaving group. So that will produce a ketone intermediate. And we've kicked out some methoxide as well. So remember that ketones have electrophilic carbonyl carbons, and so that's why we needed excess Grignard, because there's no way to isolate the ketone. As soon as it's formed, any Grignard reagent available will attack the carbonyl carbon. Just like we saw before when we started with the ketone. And that forms an alkoxide intermediate that does not have a leaving group. So we're stuck at this point until step 2, where we have introduced water. So step 2 occurs. Water is introduced, and both negatively charged oxygens will be protonated. So we can show 2 proton transfers, resulting in the tertiary alcohol. So notice that when you start with an ester, you end with a tertiary alcohol. And not only that, but 2 identical R groups will be introduced. So we had 2 propyl groups introduced. Right, and also you would get some methanol and some hydroxide as a byproduct of this last proton transfer step.